Okay, question 5, let's go. We've got a question here that is all about understanding and remembering this diagram. So, what we've got is 3 buses which enable the CPU and other parts of the processor to communicate. Now there's different things set on different buses. So the control bus sends an instruction. So what needs to be done? The address bus sends a location like this, and the data bus sends data. So if the CPU wanted to write, I don't know, 721 to memory location 5757, what we've got here is we've got an instruction which is going on the control bus. We have got a location which is going on the address bus. Sorry, those colours are rather close. And we have got some data which goes on the data bus, just like that. Now you'll notice that there is an address bus that includes both memory and input and output. This means that when your computer is talking to, for example, your monitor, or is talking to your printer, or is talking to a keyboard, or whatever it happens to be, it is just the same as if it's reading and writing data to locations in memory. So let's say it wants to write 721 to memory location 5757. So the CPU will put these values, so write, onto the control bus. It will put 5757 onto the address bus, and it will put 721 onto the data bus. Now the memory will know that 557 is in its range. It's in the range of memory. Input and output will have a different memory, so range. So maybe input and output is 0 to 1000, and then memory is 1001 upwards. So the memory knows to pick this up, and because the address is not in this range, the input and output will ignore it. Because it's right, the memory knows what it should do with it, and it picks the data up from the data bus. Now, there's several important things here. In this model, only the CPU can write to the address bus. This is now slightly different in some chips, but generally speaking, this is a good place to start. So the CPU can write to the address bus because it is talking to each of these individual components here and here. These components are not supposed to talk to each other. So the memory is not supposed to be telling your screen to do things, and your keyboard is not telling the memory to do things. It all comes via the CPU. So only the CPU writes to the address bus. And the control bus, the CPU can write to this, that's true. And it can write to the data bus, that's true. But to communicate back towards the CPU, so for example, if the CPU sends out a read instruction of memory location 5757, the memory will then put onto the control bus that here is a value coming back, and it will put onto the data bus the value that is returning. So these two values are going to then come back up on the address bus, on the control bus and on the data bus. But it doesn't need the address bus because the CPU knows that the reply is always for the CPU. So have a look at the diagram and understand it, and then we'll be able to see the answers to this question. Now, one thing a lot of people did on this question is that they didn't really get that some of these would be blank. So connects the control unit to the arithmetic and logic unit. Well, actually, none of these. That's not a good description. And sends regular signals to keep the system in time. Well, that's the clock. So it's not that one. Only the CPU can send signals on this bus. Well, that's got to be the address bus. We just said that. Must be used when writing a value to memory. So both of the remaining buses must be used when writing a value to memory, but more specific answer is we must use the data bus when writing. When reading, we don't need to use the data bus. So this would be C, and then carries instructions would be the control bus, B. So I was expecting this one and this one to be left blank. A lot of people put answers in, and I just ignored those this time round. But in the real exam, if it asks you to match these into the option that best describes it, note it says the option, not options, then you have to really think about that and do exactly what the question asks you to do. Question 5.2. The CPU runs by using the fetch execute cycle. Describe it. So I was looking for, ideally, the program counter holds the address of the next instruction to be fetched. So the program counter is used to fetch next instruction. You could have talked about buses each. At this point, I would have given you a point for that, relating back to the previous question. You can then say that the instruction is decoded, and it's decoded into an opcode. Remember the earlier question, and operator. The program counter is incremented. That means added, you add 1 to it. And then the instruction is carried out. The fetch execute cycle is really important, and you need to be able to understand it. If you can describe it in terms of the little man computer, great. But this is about the fetch execute cycle in real processors. So it works just the same way, pretty much. And you need to be able to describe these steps of what fetch is, what decode is, and what execute is. So that should be in your revision, and I'll expect people to know that next time, please. Right, we're going to go on to question 6 next.